I had gotten a few questions about volume controls, how they work, and what you do when you need to replace one. This is a wiring diagram of a volume control, and the arrow is the movable part. And here's a picture of the inside of a volume control. And let's take a closer look at how this works. Here's a volume control, and this is the center point right here where it contacts the carbon run that runs around this media here. And you can see how that works. On the back of it, it says it's a 100K. I'm going to hook up a ohm meter to this, and we'll see what it says. Okay, I've got the leads across the outer two posts, and it reads 97.2K, which is pretty close. Okay, now I've got 2 meters hooked up to this, just like this in the drawing. And this is the bottom meter, and that's the top meter. So as I turn up the volume, we see that the bottom meter is increasing in resistance and the top meter is lowering in resistance. And now the volume would be up all the way. Now I'm going to lower the volume. Now the volume would be all the way down. So a volume control is a variable voltage divider, and I'm going to show it this way because it depicts how the resistance change as you turn up the volume. Here the volume is down all the way, and that little dot to the right is the amount of signal going to the input of the audio amplifier. Now here we are turning up the volume. And here we have reached maximum volume from the source, and that is being fed into the input of the audio amplifier. Let's take a look at a volume control in a wiring diagram. And here's one, and you can see that the volume control is labeled R4, and it is 500K ohms. The signal source is coming from the secondary winding of the IF can, point A. If you take a look at point A, it goes down to the left side of the volume control, or the top. And if we continue through the resistor of the volume control, you see it's connected to the cathode, and then continues on and gets connected to R8 and then to ground. So if we got the volume all the way down, in this diagram we have 39 ohms still above ground, which means that there would be a little bit of volume still going to the amplifier. When we increase the signal by turning up the volume control, that means that the arrow of the volume control would move toward the left, toward A, which is the signal source. And of course that increase in signal will be going through C13 up to the grid of the 6Q7G, which is the input of the audio amplifier. If this volume control was bad and I had to replace it, of course an exact match would be ideal, 500K. But if I didn't have one or couldn't get one, I would go for a higher value but staying as close to 500K as possible. And the reason for the higher value is if you go to a lower value, you'll short out part of the signal from point A. And if you go with a higher value than 500K here, all that happens is the volume increases faster. And I've used, in cases like this, as much as 1 meg, and it still works very well.